termini defined the 19th century, perhaps it was Umberto Bocconi's Futurist manifesto, exalting with benzoic headiness the prophetic hegemony of the automobile, that proved to be their swan song. It ushered in a new age with a new typology of mass production as the centres of production that would now define the 20th century. So we can cue Giacomo Mattei Trucco's 1923 iconic Lingotto factory for Fiat, Owen Williams's 1932 Boots pharmaceutical building, and Frank Lloyd Wright's 1939 Johnson Wax, all in their own ways temples to mass production. This obviously saw us all the way to the end of the 20th century with Foster's Renault Centre, Richard Rogers' Inmos processor plant, and Grimshaw's 1988 FT printing works before the start of the big shed era defined by Wilkinson Eyre, that brings us all bang up to date with ubiquitous distribution centres that blossom on the outer fringes of our cities, and not least in Rugby, where I was recently, which seems to be the distribution centre epicentre of the UK. But if anything, the 21st century has seen the shift to the less formed and defined typology of the data centre, insulated boxes that with their cooling and servicing requirements mean that they're unlikely to look like anything more. Where do the possibilities lie for this building form for architects? And how do we develop a visual language for these virtual termini that allow each and every one of us to travel to the metaverse from the comfort of our own laptops? I'm not going to be asking our presenters for an answer to that particular riddle me conundrum, but I'm very happy to hear their views if they have them. But what I am looking forward to them presenting is their takes on the transport infrastructure and warehouse typology currently, to maybe give us some more pointers about where we might all be going. First up, we return to the train, a mode of transport that, thankfully, due to sustainability, has come right back into fashion as being the means of reducing car use and increasing speed and interconnectivity between our urban centres, both nationally and internationally. So our opening presenter today is Frank Anatole. I hope that's right, Frank. Principal architect of Network Rail. I've actually been trying to work out where I met Frank earlier. I think it was 20 years ago or so, so it's been a long time. But Frank has done well. He's now Network Rail's principal architect and part of the Central Technical Authority team. He has got over 30 years' experience in transport design and research, having been involved in the design of a number of high-profile and celebrated infrastructure projects, including high-speed rail stations in France, HS1 St Pancras International, London Bridge Station, and Crossrail. He was part of the design team of the London Eye and Brighton I-360 Observation Tower. He champions good design, particularly in transport and the public realm, and is a fellow of the Royal Society of Arts. Frank is going to be presenting on the work Network Rail is doing on modular stations to deliver elegant, recognisable and coherent stations that are replacing the ageing infrastructure all across the UK. Are you there, Frank?
I am here indeed.
Very good morning to you.
Good morning.
Look forward to hearing from you. I mean, I pass through Reading quite frequently, so I'm always staring at bits of it. Every time I go through, I just kind of rush through the station. So do tell us more.
I will try to do that. Okay.
You might want to put your volume up slightly. I'm not quite hearing it. Is everybody getting volume there?
Hopefully you can hear me.
Yes, got you loud and clear now.
I have to dangle this quite close to my mouth, but hopefully. Good morning, everyone. Hello. I'm delighted to be invited to speak. I'd like to talk a little bit about one of the more exciting initiatives that we're developing in Network Rail. The technical authority is a bit of, it sounds a little bit boring, and it can be. We sort of do a lot of assurance, design assurance, but very occasionally, well, more frequently now, I suppose, we're getting involved in quite some exciting initiatives. And this is one of them. This is a modular concept for a small, medium-sized station developed for the UK. It was commissioned by Network Rail and has been developed with 7 architects, Arup, LUC, and Gardner Theobald, and with a lot of strategic support from the Design Council. And it's something we've been developing for about 4 years, perhaps longer. Many events, I think, have happened since we started on this. Obviously, you know, the pandemic, climate change, there's been political, economic and social unrest, I suppose, or instability. But I think it remains vital to kind of invest in this sort of social infrastructure, so that we kind of have the proper framework and instruments, if you like, to to sort of aid recovery when we come out of the sort of current instability. And green transport is one of those instruments. So I'd like to talk about how we got here and why we sort of looked at this as an initiative. So hopefully this will move ahead. Yeah. So hub station, really, this model really addresses three challenges. The first challenge involves making stations sustainable. I'm getting a lot of feedback here. I hope that's not with my microphone. We have over 2,500 stations, with medium, small stations making up 85% of those, and the demand for them is growing. These stations can and should be massively aligned with our sustainability strategy and aspirations to be carbon neutral by 2050. The second challenge really is about a response to the government's Project Speed process. It's really to accelerate the design and delivery of key infrastructure, and we've sort of tasked ourselves with producing a benchmark industry reference design for stations that embraces four main sort of design drivers. We build only what's needed. We build sort of adaptable and reusable infrastructure. We use smart design and delivery technology, off-site fabrication, and modern methods of construction where it's appropriate. And lastly, the third challenge, to me one of the really important ones, is the government have successive governments actually have a vision for making the railways more sort of community focused. So there are various published white papers pointing to this sort of strategic direction, and it's really about sort of responding to the levelling up agenda that's under pressure at the moment, obviously, with for possible cuts to government funding, but sort of community ownership partnerships and restoring your railway and lines opening up, especially in the north of England. So one of the questions we were asking ourselves really with what we were currently building was, are we achieving any of this today? And in the course of viewing many stations, and I do that as part of my job, we come to the conclusion that we can and should be doing better. This is a £10.5 million station completed in 2021, and really it consists of a couple of platforms, some bus shelters on it, and really a huge car park for 110 cars and over 200 meters of ramps. And when you look at this, you sort of start to think, well, is it really putting passengers first? It's kind of failing in terms of its sort of ease of accessibility. Sustainability, there's a hell of a lot of steel in this. And, probably in terms of community engagement, it's not somewhere you want to spend, your Friday night. So we're asking ourselves those sort of difficult questions about the stations that we're currently building, the small stations we're currently building, and do we see this as the future of them? So about over the past 4 years, really, we've been going through a series of stages involving research, competition, consultation, and collaboration. We started in 2018 with Tomorrow's Living Station, which was a research piece by Arup, and really was speculated on the future function of stations. We moved to 2019 and we launched a program of industry stakeholder-based workshops called Think Station. They were held in 4 cities over 3 months and led by our partners in the Design Council. And they identified sort of priorities of future stations. Those stakeholders came in and told us what they felt the station should have in it, really. And this shaped the brief for a competition that we ran with the RIBA in 2020 called Reimagining Small Stations, which attracted 213 entries, and a winner, 7N Architects and their team. And at the end of 2021, we launched Explore Station, which was a two-stage national public consultation process, really on the winning design, which at the time was still on the drawing board because we'd entered into contract with the team, that design team, to develop the scheme. And we asked the British public for their feedback, thoughts, and ideas on the proposed design. And the concept that won was very kind of simple in design. It is open, it's very transparent, and the canopy kind of provides kind of shelter, and also a kind of renewable energy source. So that's what you're looking at on the screen at the moment. What makes the station concept different? It's really a kit of parts designed to suit any location. It's highly flexible, it's adaptable, and it can be tailored to any really budget. And there are 5 main elements. There's a sort of clock tower, the canopy system, what we call an activity frame, a welcome mat, which is it's another name for the public realm or landscaping, and that is actually a part of the station design, and the waiting pods or the activity pods that sit underneath the canopy or underneath the activity frame. And we're looking to provide this as a benchmarking model, I think, for future small stations on the network. The anticipation is this won't be built everywhere. It's not, a one size fits all, but it's kind of a benchmark model, and basically is a direction that we feel that we should be heading in terms of station design. We also developed a kind of implementation plan to go with this, which was basically aimed at sponsors of stations and really talks about how to implement this. So, we provided a sort of design manual and an implementation plan as part of a package of system of works. The other thing about this design is that it's very flexible. It can be configured to meet a range of station scales, from very small single platform waiting pod to a medium-sized interchange station. It has a very full small foundation footprint, but maximizes a canopy system that is kind of modular, expandable, and it's upgradable. We've just completed the Explore Station National Public Engagement Programme, which ran across 11 cities and towns across the UK. We worked closely with the Design Council to assess public viability and acceptance. This included engaging with almost 30,000 members of the public, over 30 hours of independent design advice, and someone somewhere counted 6.7 million social media impressions. Not quite sure how you do that, but they somehow managed to do it. And we showcased the project recently during the London Design Festival. What was really interesting was the stage one of Explore Station was the public response was quite varied. It was honest and instructive. People liked the design, but had reservations about exposure, security, and local identity. And there was a clear awareness of climate change. So of key importance really to them, the survey that we did was travel information, accessibility, seating and shelter, things like Wi-Fi, and amenities. Least important, actually, to my disappointment, was architectural style, but that's interesting. These comments were fed back to the designers. Stage two of the Explore Station really was about engaging directly with diverse communities and stakeholders and taking into account their needs, ensuring they were heard, understood and considered, public engagement and collaboration engagement via the commonplace online exhibitions run by the Glasshouse community led design. Urban, like the animation you see at the bottom right. And it resulted in suggestive improvements to the design, more seating, more materiality, refinement of the waiting pod. And following, I think, this process, we can have confidence that the concept has been developed and has been evolved, in collaboration with people and passengers in communities where this design may eventually be delivered. Some interesting demographics we were able to gather during this consultation process in terms of gender, ethnicity, disability and age. There was an anticipation that the programme would attract a large proportion of people sort of fit in the sort of white middle-aged male demographic, and this was kind of largely borne out. But there were efforts sort of to reach a wider group of diverse groups and focus workshops, and by holding these sort of immersive experiences. So in the end, we think ThinkStation and Explore Station programs were quite successful actually in gathering a range of diverse opinions, options, and insight. I'll run very quickly through these last slides, just to give you a little bit more kind of focus and detail in terms of the station, how it is at the moment, how it's developed. These insights really fed into quite a detailed design, which we're working on now, and we're looking to develop this into a sort of part prototype build. We've had a lot of interest from the various train companies and various sponsors, so it's something that we're developing at pace. The five main elements of design is a clock tower, there's a canopy, which is a photovoltaic canopy, there's an activity frame, the welcome mats I mentioned previously, and the waiting pods. The clock tower is a sort of, as well as being a kind of emblematic symbol, I think, of stations, it houses all the incoming services, the PV batteries, and an access ladder to the canopy. And the canopy itself provides, as well as shelter, it provides locally generated power, renewable power, and features practical kind of cassette system which allows you to upgrade it. Touched on the tower already. The tower also provides us with the opportunity to reflect local context by changing its cladding materials. So it could be timber, it could be terracotta, steel profile cladding, etc., depending on the environment. And together with the sort of feature walls at lower level, this gives designers the ability to add local character and distinctiveness to each station. Underneath the canopy, it's quite generously proportioned. It's a structure of low embodied carbon laminated timber. It brings natural warmth to an environment. There's, of course, a long history of timber structures in railway history. This one is a modern interpretation of that, really. It extends to the platform edge, providing real cover while boarding. And services are quite cleverly integrated into a sort of central services spine, which houses cables for lighting, screens, and speakers, and etc. So we're trying to do away with the clutter that you normally get with station canopies. And the PV glazing has the potential to generate up to 60% of the station's low power requirements to feed stuff like lighting, ticket machines, info systems, Wi-Fi, heating, that sort of thing. And even at sort of the smallest, even at a basic station, the option of the canopy provides sort of ambience and level of cover, amenity, lighting, and basically improves the experience of waiting. It kind of provides a spatial dimension that allows things to happen underneath it. And its extension along the platform sort of allows passengers to spread out and really kind of makes it more efficient in terms of boarding and disembarking from trains. So we're looking to move from bus shelters, if we can, to at least something of this level of cover and value, really. Moving very quickly on to the welcome mat. Now, this is the thing that really, I suppose, distinguishes this station. This is designed as part of the station itself, so it has been factored into the cost of the station. It contains an activity frame and landscaping that actually continues all the way into the station onto the platform itself. And these become a common built-in element and meeting place for social activities, and also a means to integrate climate resilient public realm design. The welcome mat means the station environment extends beyond the gate line. The activity frame is a simple, cost-effective body rope and timber pavilion that can be scaled and adapted to each location. And it creates an adaptable civic space for community uses that can accommodate a range of sort of uses, pop-up activities and other uses. And for large stations, it can be expanded to facilitate sort of coffee kiosks, parcel pickup points, etc., that sort of thing. This is a smaller version of it, small stations where it provides a flexible location for cycle parking, for example, or a weekend market, or other meanwhile activities. We're looking still at how we make the active travel zone next to the station work from a mobility, connectivity, and security point of view. And finally, we're trying to redefine the comfortable modern waiting shelter. We're so moving beyond the sort of the bus shelter to something which is a little bit more welcoming and comfortable, one that can work independently or be placed underneath the canopy or the activity framework. There's work still to be done on this, but the aspirations are a kind of transparent dual aspect waiting room with high visibility, integrated lighting, heating, customer information screens, and Wi-Fi, all powered by renewable energy. So to finish, I'll finish on this image really. It captures a lot of what we saw in the early sketches of this competition entry. You know, is this a vision of a future small station? We certainly hope so. We think Hub Station has the potential to become a reference benchmark really for us. It's unique in scale, it's local in impact, but I think it's national. A vision of a very simple, sustainable building. And perhaps most critically, it's a vision that really attempts to actively connect the station with the communities that it serves. Thank you.
Thank you very much, Frank. That was really interesting. How many stations did you say that you were planning on rolling this out? Was that 2,500? Is that an existing number? Or is that a future projected figure?
That 2,500 is the existing number. So we're not planning to roll out to 2,500 stations. But certainly there's a substantial number of what we call smaller metro stations, I suppose, that are being planned. Some new lines that are opening, new sort of, not new towns, that's slightly older concept, but yeah, new residential areas and
new urban quarters kind of.
That need stations. And stations aren't just built by Network Rail, they are built by local authorities, they're built by developers these days. So anyone can basically apply to create a station. If all of the the business case stacks up, etc. So what we're trying to do is have a ready-made model, or at least a kind of a benchmark model, so that we're designing stations which are fit for the future and that really are more than stations. They become I suppose community focus points and that enable people to to get involved and to have a place.
I mean, it's really interesting because it kind of uses that kind of up-to-date modular nature, which is really, the idea that you're using mass timber, it seems to be, and really considering the sustainability aspects of it, with something that, you know, it seems almost anachronistic to kind of have a clock tower, but there's something really charming about the idea that it's kind of like, exactly as you say, it's kind of a way of pointing the eye towards the station. It's a focus, it's kind of a civic element, which I think is a really lovely aspect of the design. It kind of strikes me as kind of that rather idealistic stuff I used to see or remember of kind of 1970s Danish train station.
Yes, precisely.
A very civic quality to it.
There's a very elemental quality to it. It's very. I mean, when we looked at this, there's a very, in the competition, we were looking at a lot of entries, 213 entries, and this kind of stood out because it wasn't trying to do architectural cartwheels, but it was a very functional building, but a very elegant building. And you could strip it back and you could add to it, and it was very, very flexible. And in many ways, you look at this and you think, well, okay, there's something quite, I don't know, mid-century about it as well, because we were looking at these sort of canopies, weren't we? It's part of the sort of, you know, British Rail days, but we didn't build them very well in many cases. And I think there's something to be said about looking back and, you know, cherry-picking elements of the past that worked, but failed for other reasons. And so I just think there's a very, very compelling story with this. And you're right, it does have it has a Scandinavian aesthetic and feel to it.
Yeah, definitely. How do you? I mean, it was a question I was going to ask as well. I mean, having, you know, fairly regular user of Chippenham Station, you know, they've only just recently dealt with accessibility issues, where previously what they had to do is kind of like ramp anybody down a ramp, actually physically cross the rails and then kind of ramp them back up on the other side. It was very, you know, arduous kind of way to get people across the platform. How are you dealing with it here? I mean, obviously this requires lifts, bridges, and obviously that's additional infrastructure, which I'm assuming is part of your modular. Yeah.
So the kit of parts for this includes the public realm. The idea is that we don't omit that. That is considered right at the start of the design. So we've costed the public realm. Obviously, it will change for certain locations. You won't always have the amount of space that we're shown in that image in front of the station, but there are options for that. We've got a landscape designer as part of the team, and we've had an accessibility consultant involved as part of the design team as well. And we've built this in as far as we can in terms of you know, accessibility of the station. That's a key aspect of its design. This sort of transparency, this you know, surety of route, this being able to see your destination without having to sort of navigate too many obstacles is key to that. So the welcome matters, the designers have called it is exactly that. It's something which is supposed to help people to get to the station and you know, do that in a highly accessible way.
So when you're saying about that, so that, are you imagining that in reality it would probably be accessibility being dealt with at kind of grade as opposed to taking people over? Would it still be that? I mean, how would you imagine it?
Well, the ideal obviously is at grade. We're trying to avoid the sort of, you know, ramps that you saw early on in the presentation. The welcome mat would build that in as part of a sort of landscape design. We've looked at various options of this on an embankment or in a cut-in and how that works. And you know, it's flexible enough that you can pull the elements of it apart and integrate that landscaping. But the important thing is to have a discussion about the landscape, and often that really doesn't happen at all. A discussion between the project team and the local authority or a developer, and by publishing this as a standard, we're not just saying, here you go, here's a design. We published it as a standard with an implementation plan that's available for everyone to look at. So developer, local authority, as well as the sponsors. And that stimulates that conversation about, well, who's going to do this? Who's going to get involved in this? And that's part of, you know, a piece
Yeah, I mean, Bob Eden here is saying, I spent my early career at Tyne and Wear Metro, new interchange stations and many of the smaller halts. Very interesting proposals here, and all in favour of increasing station distribution. How many are anticipated?
Right, so we've already had one of the main transport authorities who are looking at this for 5 stations along a new line. I can't say who that is at the moment, but and we're talking to a lot of the other, several of the other transport combined authorities who are very interested in this as a concept. The key for us really is to make sure that we develop it to a level where the quality of the detailed design is sufficient so that when it goes to the design and build contractor, we don't value engineer it down. So it loses a lot of the quality. That's our biggest fear at the moment, is that we present something which is sufficiently resolved so that there is no need to do anything that would kind of lessen its quality and its build quality.
I think it's a really nice idea, Frank, that you've got a modular system, which means that you can effectively, whether it be Bristol or Leeds or Manchester, the idea that you could kind of adopt a modular system in order to kind of to incorporate, as you say, elements of the local vernacular, be that brick or timber or whatever, it's just a really kind of pure and simple idea about taking a basic module, which you can kind of would have a kind of a national identity, but which you kind of change and to adopt vernacular elements.
Yeah, that's very much one of the things we're very keen on, is having some sort of national identity, but has a local sort of spur, a local sort of some sort of local context. We've worked very closely with the landscape designer, and really the landscaping is based on geology, local geology. There's a whole sort of pattern book basically that can be used by designers to develop their own localized scheme.
Well, I really do look forward to seeing it rolled out. I mean, it does look like a really simple elemental system that has so much potential kind of built into it. So congratulations on kind of developing it thus far. It'd be really nice to see it rolled out, and I hope we do. Thank you very much indeed for your time.
Thank you.
I do need to move on to our next speaker now, as we seem to be already running 8 minutes late, and it's only one presenter. Thank you very much, Frank. That was really interesting. Thank you. We are now moving on to Ben Hancock, our first sponsored presentation of Oscar Acoustics.
Morning.
Ben has a design background, an eye for detail, and extensive product knowledge, assisting architects and contractors in bringing acoustic concepts and designs to fruition whilst building lasting relationships. Past projects they've worked on include Warner Brothers Film Studios, a Harry Potter studio tour, the Blavatnik School of Government, which I went over to look at. It was a really amazing kind of popcorn kind of finish on the kind of the main kind of circular space there to deal with the inevitable echo issues there. Hampton Court Palace, Tate Modern, Britain, and St Ives. Hello there, Ben.
Hello, how you doing?
Good morning. I'm very good, thank you. I was actually going to mention to you in the kind of preamble before we came on live that I noticed there's actually an event tomorrow called the Noise Oscars, which I never knew about. There is an organisation that deals with the Noise Abatement Society and people making real moves to how they deal with noise abatement within our urban realm, which I thought was really fascinating. First time I've heard of it, but actually it's the 21st year apparently of the event running. Maybe you should put a few of your buildings in.
Yeah, it's nothing to do with us, but it's great marketing for us, I think.
So you're talking to us about loud and clear, the dangers of noise in industrial spaces. Yes.
Okay. Can you see my presentation? Okay.
I can. Yes, I can.
Excellent. Okay. So Oscar Acoustics is a family-run business. We're in our 44th year now, and we specialise in spray-applied acoustic architectural finishes. New research from the HSE shows that over 1 million employees in Great Britain are now exposed to levels of noise which are putting their hearing at risk, whilst 14,000 are estimated to have work-related hearing problems. The issue is systemic, and we know from our own research that many managerial workers are in the dark when it comes to their own responsibility around Noise at Work Act. Over a third were unaware, 35%, and just 38 knew roughly about the correct rules and guidelines. Current regulations stipulate that 87 dB is the maximum level of noise that workers should be exposed to. When put into context of a warehouse setting, forklift trucks clattering around operate at an average of 90 dB. This presents companies with a whole host of safety issues. So what options are available to warehouse managers, owners looking to safeguard their staff? One of the most effective ways to combat excessive noise is through the use of specially adapted acoustic sprays. They can be applied to nearly any surface, including walls and ceilings, and allow sound to be absorbed rather than reflecting it. Often warehouses are jam-packed with hard surfaces, which allow sound to bounce, rising to dangerous levels if left unchecked. A great example I like to use is a restaurant. This restaurant too is packed with hard surfaces and could have a reverberation time of 3 seconds plus. You're at your table, you're chatting to your friends, and you say the word cat. That word would bounce around the room for 3 seconds until it decayed by 60 dB. Within that 3 seconds, you continue talking and you say between 7 to 10 more words. Now, all of those words are bouncing around the room, becoming tangled and hitting you from all angles, which makes it hard to understand what's being said. And this is happening on multiple tables, creating a sonic battleground. So what do? You talk louder. This, of course, increases the volume within the space and makes it harder to understand. And the restaurant is now getting busier and the issues getting worse. People are leaning towards the centre of the table to understand their friends. The alcohol is now kicking in and the place is getting crazy. Nobody's noticed that there's music playing, but this all along has been adding to the problem. In the taxi on the way home, some people are leaving a review on TripAdvisor about noise levels, and 25%, according to research, will never return, meaning the restaurant is constantly having to attract new customers to stay in business. And here's the point. You choose not to return as the experience was unpleasant and carried a level of stress you were unprepared to pay for again. But if this is your workplace, what do? With financial pressures and a family to feed, it's not always easy to go and find another job. Okay, restaurants are an extreme case, but it demonstrates the point perfectly. High levels of poor sound quality are stressful and make people unhappy. Sometimes they don't even realise they feel like this. They just dread going to work. An employee like this is not productive and can even become toxic. What most employers don't realise is that prolonged high noise levels can actually cause serious non-hearing related health problems. The chief medical officer in England, pre-COVID, said that second only to air pollution in damaging public health, while the World Health Organization, who we've heard quite a lot about in the last few years, highlights issues such as tinnitus, sleep disturbance, heart disease, obesity, diabetes, adverse birth outcomes, and cognitive impairment in children. But there is other noise-related safety concern that should be taken just as seriously when it comes to warehousing or fulfillment centres. High noise levels in the past have led to the use of ear defenders. The problem with ear defenders is you can't hear fork trucks coming or warnings from colleagues about falling objects. Even without ear defenders, reverberant spaces tangle the sound so much that you still may not be able to hear the vehicle coming or an important warning. Emergency safety announcements are also difficult to decipher, especially for those with hearing conditions like tinnitus. Simon Wayne is Operations Director of Parcels and Post at Ascendia and has a career in e-commerce and fulfillment at major UK retailers. He says, Mechanical handling equipment is noisy. There's the beeping, the reversing vehicles, and from a safety perspective, being able to hear any warnings, beeps, etc. is very important. One very relevant thing in the last 2 years is COVID. In noisy warehouses, you tend to get closer to talk to people, and you're shouting in their faces to be heard. Voice picking is used a lot within the e-commerce sector. That's where warehouse operatives use a headset, which gives picking instructions. Users have to acknowledge instructions verbally. Now, these systems are highly sensitive and have noise suppression. They can be badly affected by noisy warehouses. It's much more difficult for people to hear instructions with fork trucks clattering around in the background or going over uneven concrete. A noisy warehouse environment thus becomes challenging to manage. So acoustic sprays are the perfect solution, dampening sound to create a safer and healthier working environment. As well as impressive acoustic performance capabilities, they're an obvious choice for warehouse owners looking for a speedy solution and minimal downtime. In most cases, installation can be finished with just one application, allowing logistics to continue as normal in the shortest time possible. We did this very thing for FedEx not long ago. If all this wasn't enough, Sonar Spray can actually add to the thermal performance of a space, reducing the heating and cooling bills, or even enabling you to reduce the specification depth of the thermal roof sheet, so you can allow the acoustic spray to do more of the work. This image is an IKEA basement car park. The product was originally used for this very reason in some of the hottest places across the world until they realised what an amazing effect it had on sound. The range has come a long way since then and is now used in all sorts of projects. This is Sonar Spray FCX, a troweled version, and it's applied directly onto a GRG ceiling. And this one's Gensler's new European HQ in London and was sprayed throughout the entire building for acoustic control. The R value of Sonar Spray is 0.03 per millimetre. So as an example, 100 millimetres of Sonar Spray K13 would give you a U value of 0.03. With thinner or thicker application depths available, depending on your requirement, you can achieve anything. Acoustically, though, 12 to 30 millimetres is plenty for most spaces. The Sonar Spray range is made from recycled paper and treated to achieve a Class O fire rating to BS 476 and an EU rating of B-S1D0, which means little or no smoke and no droplets, aiding in a safe escape. It's the only acoustic spray to be assessed by the testing body UL as being safe for use over cementitious fire sprays. Cementitious fire sprays are not normally the tidiest of applications, so it's ideal for covering them and acoustically treating and thermally treating your warehouse office space. Sonar Spray is the only acoustic product allowed within 50 millimetres of intumescent steel coatings without invalidating the fire rating. Our detail combined with superb fire performance enables us to spray right up to them, omitting the requirement for expensive and unsightly stop beads, which can also add a lot to the time of the program. It can also add value to the property by having great environmental credentials and enabling full BREEAM points. Studies shown that in some cases higher rents and occupancy levels can be achieved with higher BREEAM ratings. So it contributes to each of these environmental accreditations. It's also a low emitting building material. So it achieves, it's M1 classified, which is the best you can get for a building material, compliant with the California Department of Public Health, Green Guard Gold, BREEAM's rating for air quality. It's also got EPDs in accordance with ISO 14025, and it can contribute up to 17 points towards the lead score of a project. All installations are carried out by a fully trained in-house teams, which is important. That's all they do all the time. So it's not a dry lining company having a go at a spray job every now and again. They specialise in it. And to complete the environmental jigsaw, Oscar Acoustics are ISO 14001 certified. So due to popularity of the product, we've hugely outgrown our current premises and are about to start building our new 16,000 square foot Oscar Innovation Centre. This comprises of a large warehouse and product development facility cloaked by a brick facade, hiding the warehouse from the road and the houses opposite. The long building is 6 separate double-height industrial units, some of which will initially be let to local innovative companies on short-term lets. This will give Oscar Acoustics room for further growth. The scheme's been designed with urban and rural architects and has been welcomed by the local community. It's had no opposition at all from anyone around, including all the houses opposite, which was nice. I'm not going to go into too much detail on this today, as I'm going to save the whole project for a future presentation. It's extremely exciting for us, though, as you can imagine. The plan's to make it a great place to work whilst fulfilling our storage and logistics needs, which have become challenging. In order to aid collaboration, the space is to be open plan with bifold partitions for private meetings and presenting webinars like this. It's also being designed as a show home for all our acoustic products, so please do let us know if you'd like to visit once built. And to finish off, here's an image of part of the warehouse just to keep it relevant. The plan eventually is to install a mezzanine level as well to increase capacity further still as we grow. So that's it from me. Thank you very much. Please do follow us on social media channels or send me a LinkedIn invite to see our projects. You can also download our latest white paper on acoustic treatment in the workplace, which is fascinating. The results are great. I'm Ben Hancock. Thank you very much.
Thanks a lot, Ben. Just a quick question about the sonar spray. I mean, you obviously in factory environments, you've kind of put it at a really high level. Now, I remember, I think it was sonar spray, was it? They got used at the Blavatnik. It's obviously quite, it's very tactile, but I'm sure you probably don't want to be running your hands all over it. I mean, it is very spongy and nice, but would you kind of advise that you kind of generally keep it out of hands reach?
So if you were to use it, say, for instance, in a sports hall, that's about the harshest environment you can get. Normally, we'd say put it above head height, and then it's out of the way and it's doing its job. It might get hit by footballs and what have you, but that really doesn't matter. Okay. If you were to need it at lower level in a factory, there is actually a harder coating that can be sprayed over it. And what they've done in the past is to spray it on the walls at low level, but actually put a handrail maybe 500 mil away, and that does the job. Yeah, it's I mean, it's quite. I mean, just as I was thinking about it more generally when you were talking about the issues of kind of noise within office spaces, and I mean, obviously, there's with new workspaces and stuff. Obviously, I suppose your products are more specified because everybody wants to kind of see the the concrete soffits and the kind of the exposed surface aesthetic that's going on. It's been popular now for probably decades, but more so now, I think. But I certainly know that noise is, I mean, do you think COVID has had an effect? Because I certainly know that in our workplace and even at the RIBA that we've got more echoes because actually I think there's more resistance to using fabric materials within office environments to kind of deal with, to kind of soak up the sound because obviously you can't clean it, it's harder to kind of manage. So in terms of facilities management, I think we're seeing more hard surfaces getting introduced into office spaces because they're just easier to keep clean and use that antibacterial finishes on cleaning products. So do you find that there's actually kind of more noise within workspaces? Do you feel that? There definitely is. You see a lot of, Instagram, you see a lot of photos with bare rib deck or concrete slabs in offices. It just creates this sonic battleground, a term I love now, which is why the sprays are ideal because on the most part, you put them on the ceiling and they're just there out of their way doing their job. And if you're installing it in a warehouse, we'd recommend, you probably don't want to go for the white finish. We've put white in Jaguar Land Rover's factory plant, but that's a fairly clinical thing. If you've got a factory or warehouse with dust, you might go for a light grey or a mid grey, something like that. So it's ideal.
We've got a question from Adam Pearson saying, what's the product made of and what under its constituents source? Well, I think you answered the first part of the question, but maybe not the second.
Okay. Yeah. So it is made of 90% post-consumer recycled paper. And then it's got water-based adhesives as well. So, which is why it manages to achieve all these incredible environmental credentials, and also the emissions as well. Emissions are a big thing now. You want low-emitting materials within your workspace, and that includes warehousing as well. It's no different. It's just a workplace.
And a question from a staffer saying, is it fire resistant? Well, I think you noted that as being compliant with BS 476 and with Class O fire rating.
That's it. And actually on YouTube, on our YouTube channel, there's this fascinating in a nerdy way, but fascinating comparison. It was a fire test that was done, and it's been visualized in an animation, and they were comparing a fiberglass with a sonar spray, and they had the flame burners going underneath, and it was up to about, I think it got up to maybe 10 minutes, and the fiberglass had just completely disappeared, and it was actually burning the test bay. Our stuff was in place for 20 minutes. It was all still intact, and it was actually protecting what was underneath. There's a world famous film studios as well that had a very big fire not too long ago, and I went to view the studios afterwards, and our finish was pretty much the only thing still intact. That and the frame, but yeah, it was nice to see. Well, not that.
It looks like that one will kind of work to your advantage in your new HQ, which I hope to visit at some point in order to see quite how much sound you're absorbing. I think it'll probably sound pretty much like a radio studio, I hope, or at least that's what I'm...
Yes, that's it. You're quite welcome.
No, I'll pop along. Thank you very much indeed, Ben. I'm sorry.
Thank you.
I apologise, everybody. Sorry about that. Our next speaker today, I believe you're there, Hugo. Are you there?
Yes, I'm here. Hello.
Good morning, Hugo. Hugo's going to be speaking to us. He's from Haworth Tompkins, Associate Director at Haworth Tompkins, and he's going to be speaking to us about their Industria project. Hugo leads on the industrial intensification team with Graham Haworth at Haworth Tompkins, and is working on two major innovative multi-level industrial schemes at Albert Island and the Royal Docks and Industria Embarking. He's got 20 years experience delivering these projects on challenging urban sites across a range of sectors and clients. Prior to joining Haworth Tompkins, he was director at Meadowcroft Griffin Architects, focusing on education and community projects for local authority clients. Hugo, you're talking about Industria Embarking and Dagenham with Be First, which is an innovative and ambitious approach to modern industrial design, providing light industrial units and maker spaces to fit current needs. You ready to go?
Yeah, thanks very much.
Good. Look forward to hearing it.
So we've been working in the industrial sector for about 5 years now, and I thought I'd start with a sort of broader introduction to the sector generally, and the master plan in which Industria sits. So it's a sector that's characterised by a lot of change over the last few years. London has lost a lot of industrial land over the course of the last 30 to 40 years. There's something like 1,500 hectares since 2000, which has driven a market and a need for industrial space. As well as that, there's structural changes within the industry. The demand for logistics space has been driven by a year-on-year growth in e-commerce. And of course, COVID in the last few years has accelerated that. So major lifestyle changes, more online shopping has also driven that need. And then in addition to that, there are a whole range of new users in the sector, such as urban farming, last mile logistics, dark kitchens, specialist wholesale uses, battery buildings and so forth, that are broadly termed new industry that have been introduced to the sector, also operating, out of those industrial spaces. We got involved in parking about 4 years ago now. So we carried out a master plan and vision piece for the Thames Road, River Road area for B First. And this is a district, as you can see, it's largely made up of traditional single-storey crinkly tin sheds of various ages. The borough had overarching placemaking aims to rezone some of the land within the master plan. So the three images on the left of this slide illustrate those zones as a phased master plan over time. The pink at the far right-hand end of Thames Road were parts of industrial sill land that we wanted to look at rezoning for residential uses to better connect residential areas on either side of Thames Road. And the purple in the middle of the plan was an area that we ended up zoning as co-location uses, so industrial and residential uses, typically cleaner industrial uses existing alongside each other or stacked one above each other. And then the yellow in the center of those plans is an area earmarked for industrial intensification. So in simple terms, in order to release some sites for residential use, which the borough wanted to do, we're required to demonstrate through the master plan that we could intensify industrial floor space uses in other parts of the site to preserve the amount of industrial floor space in the overall sill area and allow it to be increased and modernised over time. So that's the driver really for industrial intensification, as it's termed in this area. And our site, Industria, sits in the centre of that yellow zone. So it's one of the plots where we're looking to intensify floor space within the borough. So we carried out that master plan starting in 2019. We were then fortunate enough to win the opportunity to deliver one of the first buildings within the master plan, which is called Industria. And the vision really for the scheme, as far as the borough is concerned, is that it should be an exemplar to catalyse the market in industrial development within the area and to demonstrate that multi-level industrial space can be a viable commercial way of developing a site. So this is our scheme that you see on the screen in front of you now. It's 3 levels of industrial space with two wings of light industrial units arranged around a series of yards stacked vertically in the middle of the site. And it will be the first in the UK of its kind as a multi-level light industrial trading estate. So it's a very innovative and exciting project to be involved in. We get around 11,000 square metres of floor space in the scheme overall, and that's mostly aimed at the smaller end of industrial units. So we've got light industrial units of between 300 and 500 square metres, and then 2 floors in one wing of smaller makerspace or flatted factory units, as we call them, that range between 20 and 100 square metres. The 3 levels of decks are served by a helical vehicle ramp, so which is van access only to the upper level decks. So HGV deliveries are dealt with via a loading bay on ground floor and goods lifts that rise up through the building with vans and shorter rigid vehicles, cars going up the decks to service the units. And these type of units, they're aimed at traditional range of light industrial tenants. So they're typically people who want to have van access with a roller shutter to the front of their unit. And you can see in the section on the right-hand side of the scheme, the units themselves are quite tall. So the typical story height is around 8 metres tall. And the dark blue units are those light industrial 8 metre tall SME units, with then one of the wings divided into 2 floors, what we would call flatted factory units that they're around 4 metres tall. There's very heavy floor loadings required for these types of schemes. So ground floor is 25 kilonewton loading. The typical upper floors are 15 kilonewtons, and then the flatted factory floors are vary between 7.5 and 10 kilonewtons, so significantly higher than traditional commercial or residential space. And that sort of drives the structure really for the scheme. So we've got a large steel frame, very heavy, large section sizes to deal with those loads. The frame grid is traditionally an 8 metre by 8 metre or 8 by 16 in an industrial setting, and that's to deliver flexibility and suit the racking requirements of tenants and so forth. So steel's an obvious choice from the point of view of achieving those wide spans to deliver that flexibility of users, and also in terms of cost and speed on projects like this. And I'll talk a bit about the kind of viability challenges in a minute, but I mean, really, the reason this type of multi-level development hasn't happened historically is that the kind of viability equation of build costs and industrial rent and industrial land values has meant it hasn't been viable or attractive to developers. So actually for us, delivering the scheme on budget to meet that viability was really key to proving the concept and making the scheme successful. These site shots are from a few months ago now, so we are about 3/4 of the way through the build, due to finish in February, March next year. I've got a short video, some drone footage that the contractor's been supplying of the build as it goes on, where you can see the two wings under construction and the decks running through the middle. So it's quite a tight site. We've pushed right out to close to the boundaries on all sides, as far as we can really, to try and maximise the floor space intensification that we're achieving across the sites. And we're working on a short promotional film that's you'll hopefully see in a month or two's time to coincide with the marketing of the units that will incorporate some more of this drone footage. So in terms of the products that I thought I'd talk about today, really, in a way, the most interesting for us are probably the cladding products that we've used. We've had to learn about some new types of systems to deliver this building. There are three main cladding systems that we've used. So on the outer-facing street facades of the building, we've got a panelised precast concrete facade system used on the ground floors, which is very robust and textured and gives life and quality to those facades that are nearest to the street. And that alternates with double height glazed shop front openings on the ground floor to animate and give views of what's happening within. Then on the upper levels of the street facing facades, we have a very simple, elegant, crisp black metal cladding system. And then thirdly, on the interior deck facing facades of the building, we've got a more playful, textured, profiled metal system. So the stripy pajamas, as it's been termed, which you see peeking out at the entrance and on the open deck ends of the building. We've also worked with graphic designers DN & Co to deliver some really large format super graphics and signage that appears around the building facades and really uses that kind of very restrained, elegant black cladding system as a backdrop for that. The concrete system is a precast panel. Each panel is about 1.1 metre wide by 7.5 metres tall, so they're really, really big things. They use a Reckley mould system. So if you know Reckley, they're a supplier who has a series of rubber mould designs of very beautiful, elegant textured patterns for precast panels. We went with a sort of deep and large pebble pattern to, as I say, to try and give life and character and something a little bit surprising actually within the context of industrial buildings. We started off with the panels at twice the width, 2.2 metres wide, and then because of the crane logistics and cost issues, those are reduced down to 1.1 and lined through with the metal panels above. That's delivered to site as a single piece craned into place, and then there's a rock wall type insulation applied to the back of them and an inner lining of stud, more insulation, and a cementitious board for robustness. So we've got very good U values and air tightness targets. Generally, the intention is to create a really high quality building that's got the quality and the flexibility to be in use for hundreds of years, we hope, in the way that the industrial buildings of the past have been. And we're achieving, at the moment, BREEAM Excellent for the building as we stand. And the second system I mentioned is the composite panelised metal facades. So this is really a kind of modern version of what you would see if you drive up the M1 and you see the big logistics sheds, so an Amazon or a Ocado shed. And it's a very efficient approach to building a wall. It's basically a sandwich of 270 mil of mineral wool fibre with a pre-coated steel panel on either side of it. Simple kind of click together fixing system where the panels are tongue and grooved, and you joint each one through the groove, so you get a concealed fixing joint to joint, and very, very fast to install. So as delivering the project quickly was key to keeping keeping on budget and delivering on the viability. So we've worked very hard to take what's effectively a sort of traditional shed system, but give it some refinement and quality by how we work the joints and align the joints. So, for example, at the horizontal joint between panels, typically that's a kind of a flashing detail, and it's not the prettiest of things. So in our design, we've concealed that behind a projecting horizontal rail detail that gives a bit of animation and composition to the facades while providing a neater finish overall. And to give you some kind of context in cost terms, we're sort of aiming to deliver this building at just over £2,000 a square metre. That was a sort of original target. And these facade systems, so this upper level facade might be coming in at £300 to £400 per square metre for the whole build up, which is very low compared to traditional residential masonry or so on. And that's a Eurobond system from Euroclad. So I should have said all of these facade systems are A2 rated, fully non-combustible. That's not yet a hardline building regs requirement for these types of industrial building, but it is best practice, and there's a belief that it may well become building regs requirement in the relatively near future. So for best practice, quality, longevity, and kind of insurability issues, we've taken an approach that it should all be A2 rated. Then on the inner decks, as I said, this is a sort of planning stage visualization of those internal stacked loading decks, where you can see the roller shutters of the unit. We've used what's called a built-up system, so it's a profiled corrugated metal panel, but it's rather than being off-site fabricated like the first two cladding systems, it's actually put together on site, a bit like a stud wall. But again, a very simple, slim, efficient system overall. So it's a mineral wool core with a metal panel on either side around a metal stud system. And DN & Co have worked up a graphic logo for the building, which is an abstracted spiral form representing the ramp that is then transformed into a checkered pattern finish that runs across these interior facades. So you can see some of the design drawings working up how to apply that checkered pattern. Again, I think what we're really interested in is a building that's unashamedly industrial in character, but which has got the kind of life and liveliness and design quality that you'd see applied to a school or a museum or a good residential project. So here's a couple of images of that built-up profiled metal facade system going in on site. And that again is from Euroclad, the Elite 60 system. Again, very good air tightness and U values achieved. So overall, as I've said, we're really excited to be innovating, bringing forward one of the first of this typology of building in the UK. And I suppose our sort of vision or stated aim is to deliver a generation of industrial buildings that are as beautiful, flexible, and long-lasting as the best examples which we've been left with from the past. So that's me. Thank you very much.
Thank you very much, Hugo. A very interesting project. And like you say, I mean, the thing is you built it in for longevity. It's interesting coming from a firm that I know have really, think really long and hard about about how they create a sustainable approach for all their buildings. Purely for I suppose, it is a very, very hard-working building. I mean, the fact that you've kind of chosen concrete and steel, I find quite interesting. I mean, did you kind of were you kind of whirring around a lot in your head about how you might be able to do this out of mass timber or how it might be workable in other materials?
Yeah, we did look at that quite hard. I think that the truth is, the building is a real stretch in terms of innovation and viability and risk for the client at the moment. So, they're taking quite a lot of risk. I mean, everybody in the industry who's interested in seeing where the stacked multi-level industrial really can work and stack up are kind of going to be watching with interest as BEfirst let this building out. And there's a great deal of skepticism or concern, if you like, from the market generally in terms of investors and other developers as to whether it will work. So I think our fervent hope would be that the next building we do like this, or in a couple of buildings' time, we will get timber frame into the equation. But it was just a bit of a reach too far on this stage, and it's really because of the floor loadings. As I said, those kind of 15 kilonewton upper floors, we've got steel beams that are close to a metre deep already, and pushing the envelope very hard on those. So there are not yet any built examples, as far as I'm aware, globally, of a genuine stacked industrial scheme in timber structure because of those restrictions. There are a few very good examples of timber frame single-story logistics shed. The Witzo factory, for example. There are Austrian examples. So it is happening and beginning to happen. But for genuine multi-level proper industrial loadings, we don't have one of those yet. So we hope we might be standing here in a few years' time presenting the first of those as well.
Good. I've got a question from Ian here that says, does BREEAM excellent rating ensure that the GLA is satisfied with that their sustainability aspirations are being met?
I think I would say yes, as far as this project goes. I mean, the GLA are a sort of partner with BEfirst in the enterprise. They're actually taking a head lease on a certain proportion of the project, so they've been part of the client group all the way through. And yes, so BREEAM Excellent was achieving the minimum brief that we had from them for those. As I say, I think it's a very fast evolving field, and what was considered ambitious 2 or 3 years ago when we sort of really started designing the kind of technical aspects will probably be seen as business as usual in 2 or 3 years' time. So we're working on stacked industrial schemes now where BREEAM Outstanding and net zero in operational and embodied is more like the sort of baseline target for the next generation of market leading buildings. So it is changing quickly.
Good. We have a question from Terry. Is it a speculative scheme or have tenants come on board from inception?
No, it's entirely speculative. So there were no pre-lets. BEfirst are going through the marketing process at the moment to find tenants.
And Bob says here, multiple users and activities must raise a huge number of concerns regarding fire control, ventilation and security.
Yes, they do. So the fire, ventilation and security issues are all really complicated. And, you can imagine also the thermal detailing for, we've got a situation where structure supporting external yards is connected to structure supporting internal floor space. So you've got really, really quite challenging connection details in terms of thermal breaks and fire breaks at those junctions. The ventilation is simplified to some degree in that obviously the loading decks, the way you've got vehicle movements, they're open at both ends. So they've got a lot of through vent via the open ends. I didn't talk about it in much detail, but we've got a green wall, a simple sort of trellis system for planting, growing up those ends as well, to give sort of urban greening factor and wellness as far as the employees are concerned. But yeah, it is complicated, and we've learned a lot. It's the first of these buildings we've designed or anyone's designed properly in the UK. So we've learned a lot as we've gone along.
Well, you've got 3 fans here. You've got Terry saying, well done, a breath of fresh air for industrial design. Bob saying in terms of quality, it's terrific to see the outcome exceed the imaging. And Mustafa saying that it's amazing work. I'm just intrigued. I mean, having looked at these enormous, 8 meters is quite something really for a unit height, which you're kind of stacking. You say it's you kind of imagining it for hundreds of years use. Can you kind of imagine a scenario where, it seems almost to me that you could, I can almost see a live-work scenario going on there. I mean, with like, you know, even in like say 50 years with change of regs or whatever, I can almost see, you know, you're getting a three-story house in one of those things almost. I can almost see that change of use happening, or at least 2 stories above a, you know, a kind of a work unit at the lower level. I mean, there's just, you know, given the heights that you've kind of built in, the inherent flexibility you built in there, it seems like there's future for different, you know, absorbing a different kind of typology in there.
Yeah, I mean, the units and the structure is designed so that you can insert mezzanine. So your sort of traditional modern single-story industrial estate on the ground, you know, might typically be built with a unit that's perhaps, you know, 15 meters by 25 meters with a mezzanine across a quarter or a third of it, where you might have office above and toilet below, or so forth. So that's the kind of fairly standard industrial model that you would have the ability to mezzanine out your space, and a lot of tenants will want to do that. So that structural contingency is built into the scheme, and I totally agree. I think, you know, you've got to put yourself in the mind of a Victorian mill architect and think what did they imagine might happen in those spaces. In fact, all kinds of things, right? Like in a way, we've got a term in our practice which is useless buildings. So a building that doesn't have a specified use at the start of its life. So that sort of mantra of flexibility and you know, trying to an open-endedness, I suppose, is really the core design vision to the whole thing.
Yeah. Oh, well, thank you very much indeed, Hugo. Fascinating project. Let's talk more about it, but I'm seeing the clock here ticking away. Thank you very much indeed for your time. Great project. We look forward to seeing it. You're saying it's completing March or next year?
PC in end of February, early March.
Okay, well, get in touch, because we'd probably like to take a look at that one in a bit more detail, maybe.
Perfect. Thank you very much.
Thanks a lot. Thank you, everybody, for your presentation so far. I realise I'm now running 17 minutes over. I'm being really bad, so I apologise in advance. We'll probably take only 5 minutes or so maybe back at 10:23 or so. We'll see you then. Thank you very much. Welcome back, everybody. It's now 10:25. I realise I'm running a little bit late, exactly 15 minutes, so apologies about that. I'm not very good at controlling times here, but I tend to get rather taken up with the conversations. Our next presentation is our second sponsored presentation, Mapei, from Tim Boarer, Head of Specification, London and South at Mapei. He is the Head of Specification for London and South, assisting specifiers with the selection of Mapei's range of over 6,000 construction products. Tim and his team provide advice on their products, helping specifiers achieve technical, aesthetic, functional, programmatic and sustainability aims. He's got 10 years experience, broad range of material types and applications, including concrete, screeds, adhesives, waterproofing and resin-based materials. You will be speaking, Tim, on 15 minutes, is it 10 minutes? 15 minutes on Mapei fast track systems to transport hubs and stations. Good morning, you there?
Good morning, Carlos. Good morning, everyone.
Hello, Tim.
Hi, can you hear me?
Yes, can indeed.
Yes.
Take it away. I'll just mute myself here so that, take it away.
Fantastic, thank you. Okay, good morning, everyone. Nice to be presenting to you today, and on the topic of fast track systems for transport hubs and stations, and really just a very brief introduction on Mapei's range of products for these types of applications. So Mapei as a company is a worldwide construction materials manufacturer. We are 85 years old this year. We operate in over 57 countries around the world, with research centres dotted around globally, including one here in the UK, as well as our manufacturing facilities. So Mapei has a vast amount of experience in manufacturing supply of construction materials for the rail and underground sector. And that experience ranges from infrastructure works, as you can see there in the bottom left-hand picture, the bank station capacity upgrade, where we supplied our spray-applied waterproofing systems for the shafts and tunnels there, right through to refurbishment and new construction of stations and transport hubs. Our goal when we produce materials is that we ensure that they're compatible with other materials in our range, so that we provide complete solutions and complete systems. So when we're looking at floor build-ups, for example, for a tiled finished floor in a station, we're thinking not just about adhesive and grout for tiles, but also all of the subfloor build-up that goes into the floor construction and requirements that may be there in terms of application thickness, drying times, strength, etc. So hopefully the next few slides will give a very brief overview on the types of materials that we can assist with an emphasis on speed for fast track systems, so speed of application particularly. The vast majority of the products mentioned have been used on the London Underground and TfL projects in the past. So that's just a brief overview of the range of products that or product lines that we have within Mapei. So we have multiple products within each of these lines, but just gives an idea of the breadth of product types that Mapei produces. So when we're thinking about materials for fast track systems, what are some of the things that we're thinking about? And by no means an exhaustive list, but I think important to share some of the considerations, certainly from us as manufacturers and in our conversations with specifiers. When we're looking at materials, whether it's a repair mortar for repairing concrete or an adhesive bonding a tile to a substrate, we need to be thinking about mechanical properties in as much as compressive strength, flexural strength, E-modulus, the speed of strength gain, so particularly for fast track systems, how quickly products are gaining strength. A requirement that we have often in applications such as London Underground for refurbishment works is that, for example, screeds are removed, reinstated and put back into service so that people can walk on a tiled layer on them the next day, for example. So designed for that very, very high strength gain using various cement technologies to ensure that we get that sort of speed. Aesthetic and functional properties. From Mapei's point of view, a lot of products that we supply are beneath the finish layer, but obviously a very important aspect, the visual appeal. But then within the environment of stations, concourses, but also in areas such as warehouses that we know we're talking about today as well, functional properties such as resistance to wear, resistance to cleaning, slip resistance, all very important properties. In addition to the application thickness, so if we can reduce our material thickness, for example, again within a screed context, it may be we can increase the amount of insulation or generally decrease the amount of material that's used. So the effect on program from our fast track system point of view is to reduce drying times of materials. A lot of cement-based materials, such as those using concrete and screeds, adhesive products, leveling compounds, these types of materials often have quite extended drying times when we look at traditional cements. So using pollen-modified materials that significantly speed up our drying times. Speed of application, how quickly we can get materials into place, and then how quickly these materials can be trafficked as well. And then, of course, very importantly, to be thinking about sustainability properties of materials. Here at Mapei, we measure our materials across a number of matrices, including VOC content that we measure to the GEV EMI-code system. So something that you can find on data sheets of products. Whether they qualify for any LEED or BREEAM points. ECO2, embodied carbon within materials. A lot of our products now have EPD certificates attached to them that give quite detailed information on the carbon footprint from cradle to grave. Excuse me. Excuse me. Dust and applicator safety as well. Please excuse me, been suffering from a cold. So when we look at some typical build-ups within station environments, excuse me. So looking at some typical build-ups then for these systems, for fast-track systems. And we'll look at a few of these in a little bit more detail. So, for example, in ticket hall areas, concourse areas, station areas, some of the build-ups that we can see here from the concrete slab upwards, from the slab through the screed, through the tile layer, we can see then the need for very high performing materials in terms of resistance to quite intensive traffic that we can expect to find in these types of areas. For example, in ticket halls and concourse areas, it's likely that we're not just going to have pedestrian traffic, but also trolley wheel traffic as well. And so the need for high strength materials very much comes into play. So from a strength point of view. And of course, when it comes to tiling, looking at solid bed adhesives, the use of anti-fracture matting, for example, as well as very abrasion resistant tile grout. Also within our subfloor build-ups and subwall build-ups, when we're looking at our need for screeds and renders underneath our finished layers. As I mentioned previously, for traditional cement-based materials, we're looking at very extended drying times for traditional sand cement-based renders and screeds, often that can take a number of weeks to dry out. At Mapei, we have a number of products formulated to allow for tile and finish applications to take place after just a few days. Thereby sort of negating the need for wasted time in terms of program on site. Similarly, with waterproofing systems, so for example, our Maplastic Turbo shown here, it's very thinly applied, just a 2 mil applied polymer modified cement-based waterproofing membrane. It's very, very flexible material. Again, allows for tile installation after just 4 hours. So very, very quick once being applied on site. The final section we're looking at here is for a warehouse or back of house areas in stations, for example. Here we have options for resin or cementitious-based finishes with different aesthetic and functional performance. But again, these can be applied very, very thinly, but provide a very high-strength, abrasion-resistant floor suited for warehouse environments. Quick to receive traffic after they've been installed. So anywhere between 3 to 4 hours up to a couple of days after installation, depending on the system type used. These have very high chemical resistance as well. If we're handling different types of materials that perhaps are aggressive to the surfacing on the floor, then we can have high resistance in our finish as well. So just to finally mention a few different case studies where these types of materials have been used. So at Bond Street Station for Crossrail, fairly recently. So over 5,000 square meters of tiling used here. And of course, a pretty high intensity area in terms of foot traffic. So here, use of high strength adhesives, subfloor build-ups that allow for step-free access from the street to the platform. So you can imagine here we're looking at numerous ramped areas where we're bringing our tile layer continuously through from street to platform. Birmingham New Street Station, a few years ago now for Mace, and 20,000 square metres of our system for screed up to tile, as well as our industrial strength levelling compound for the concourse areas. And then here at Holland Park Tube Station, we're involved in a lot of refurbishment works for London Underground. And very often speed here again comes into play in terms of refurbishment. So here using our render over tile system, so existing tiles that are left in place, we have a system that allows for rendering directly over the top of the tile layer to then receive a paint system that has incredibly low dirt pickup and good cleanability, which means that this operation doesn't have to necessarily involve stripping back to the substrate. Tiles can stay in place and the station areas can be refurbished very quickly. And then finally here at Victoria Station, so this is a building that was just outside Victoria Station, owned by Transport for London. And the gable elevation here to the building was found to be weak, friable and unsafe. And so using our fibre reinforced render system, structural connections between the end and flank walls were improved. So it's using an NHL, naturally hydraulic line-based render, which encapsulates a very high-performance fibre mesh within the coats. So I hope that's been a quick sort of whistle-stop tour introduction, and excuse my my cold again. I hope it didn't interrupt the presentation too much, and gave a bit of an introduction as to the types of materials and systems that we can offer.
Thank you, Tim. Tim, you need some Benylin.
I think so. Yeah, absolutely. Thank
you for struggling through there. I really felt for you a moment. I was thinking, I'll take over, but I don't know anything about products. Well done for managing that.
Thank you
for that. It was a good broad overview. The question that kept going around in my head was, I know that from remembrance, Mapei's got this kind of very curious looking HQ building, which is, prides itself on the use of kind of sustainable materials throughout. That's my remembrance of Mapei's HQ. How is it that you managed to kind of get, because you keep talking about how everything shaves time off the program because you can actually just kind of use your Mapei products in they're all quick drying and they all work really quickly. And I'm just thinking, generally, in the old days, I used to just associate quick drying with generally being absolutely chock-a-block for VOCs. So I take it that's not the case. I mean, you're managing to use polymer-based additives which speed the process, but which are all somehow sustainable. Is that the case?
Yeah, it's a really good point. So yes, it's I would say down to some clever chemists that we employ within Mapei, and quite a number of them around the world, that we invest very heavily in looking at formulations for materials that allow us to reduce VOC content, particularly within cementitious-based products. But increase the performance as well in terms of strength, drying times, adhesion properties, and so on. So, certainly a lot of investment that goes into developing those types of materials. A lot of products still within the industry for those types of applications are cement-based, so are using cement as their main component. Cement obviously having a fairly high embodied carbon. There is scope for replacing Portland cement with things like GGBS and PFA within mortars and screed products as well. And that is something that we do, has an effect on the materials performance, particularly in terms of strength gain generally. But is certainly something we do where we can.
I mean, I looked at, I mean, you know, you gave us Bond Street Station, obviously an ongoing project. I've seen Birmingham New Street. I suppose of all of those, I was most intrigued by the Victoria Station one, because I was rather intrigued by the idea of a carbon fibre reinforced kind of coating material that kind of increases the structural, you know, effectively the kind of like pulling kind of flank walls together in a sense. You said it was a line-based render with carbon fibre in it. I mean, give me a bit more of a description. I'm kind of quite intrigued by that one. I don't know why. It looks so nice as well. Really nice, fine grey icing all over the building that I find rather visually alluring. Yeah, and there's sort of a Prosecco glass shape actually in the elevation there. You can see in the render, which is quite interesting. It forms part of a range we have. More broadly, which is called FRP, fibre reinforced polymers, and it's always one that people are interested in because it's you know, this perception of it being a very, very modern technology. FRP encapsulating things like carbon fibre used in construction. Well, it's also the breathability aspect of it, though. The line, kind of going back to really old school, but kind of brought into the 21st. Yeah, absolutely. So absolutely right. So an NHL based render, but still with high mechanical performance, but the breathability as well. And it's basically a line-based render that has a carbon fibre mesh encapsulated within 2 layers of the build-up, and so you get this stitching effect that if you were trying to stitch together a masonry elevation due to movement or settlement or shear, for example, then this is quite a thinly applied render over the surface. That still remains breathable from masonry underneath, but gives it that strength and stability. Oh, well, congratulations. I look forward to passing Victoria at some point and staring at that wall before they bloody awful right next to it. Architects. Focusing on infrastructure and public realm projects, he's a bridge design specialist and defining and resolving complex three-dimensional geometries. He believes that intense collaboration is the key to the best architecture, which should convey a sense of inevitability and belonging. I'd love to know what you mean by inevitability and belonging there, Ezra. He draws from long experience running and contributing to large and small projects in the UK and abroad, and brings solution-focused design approach to all of his work, regardless of scale, scope, or location. Ezra, you're talking about the Esperance Bridge at King's Cross, named by the children of a nearby school, a simple yet elegant bridge inspired by the area's industrial past. Now, I'm used to walking over your bridge over, as I said earlier, the one that crosses over by the Camley Street Natural Park. This one's on the other side, isn't it?
Yeah, and I'm actually going to use that one as an introduction to this bridge.
Okay,
so you'll get a 2-for-1.
Oh, yes, always nice to pop over to that side of Coal Drops Yard. I had some friends who had a barge on that side as well, so I saw that bridge going up quite often whilst out on the lock side. So good memories of that one. Please go ahead.
Great. Well, thank you, Carlos. Thanks for having me. I'm quite excited to be here presenting this project, which opened about a year and a half ago. So, like I said, I'll be talking about an area we've been working on for some time now. I think anyone who's familiar with London or lives in London probably has come across this development. I believe it's one of Europe's largest urban regeneration projects. It's right in the center of London, just north of King's Cross Station, St. Pancras Station. And I think one of the most inspiring things, or one of the things that's really gotten right, is its emphasis, or the kind of weight it places on the public realm. It's virtually a car-free neighborhood, and I think it's a great example of what can happen if you kind of give all the open space over to people. One of the main drawings within the original planning permission submission was this kind of Noli map style urban realm drawing, and it just shows how important it is and how important it's been from the beginning. So it's kind of the relevance within this infrastructure discussion. Just to state the obvious, none of this is possible without a really strong team. Pretty much the same design team for both of these bridges I'm going to talk about, and kind of amazing client leadership from Argent, who are the developer, who really know what they're doing, and they put a lot of faith in their designers, which just creates a great relationship. I think bridges, especially, I enjoy working on them because of the close collaboration, and I think these are great examples of kind of engineering and architecture merging seamlessly. We kind of have a very well-balanced structure in the design team. So as I said, it's super central. King's Cross is a really interesting neighborhood in that back in Victorian times, it was the center of transport and industry. You had kind of rail corridors coming down from the north, and then you have the Regent's Canal cutting through it east-west. So those were the elements that made it successful from a transport and industry perspective. As that died off, it made it incredibly hard to repurpose or redevelop. So the site kind of lied dormant for a long time, very difficult to develop. And only recently, in the last kind of generation, has a developer kind of ambitious enough to take on the whole site has made it happen. So the canal and the rail corridor, which at one point kind of made things possible, then made it very divided and isolated. And now those things are actually, I think, seen as positive qualities. The canal obviously is a positive feature, and the access to transport is one of the draws to this development, and it's why people want to live here. So central, yet so well connected to the rest of London, the rest of the UK, and even Europe. So I'm going to quickly talk about Somerstown Bridge, which, as Carlos said, was one I think was built around 5 years ago. And it is the westernmost bridge of the development. It was a challenging bridge to design in that on the kind of Coal Drops Yard side, you're entering the bridge at high level atop a series of historic brick arches, and then it's connecting. That's kind of the point A, and the point B is all the way down to Camley Street, which is about 5 meters lower. You're passing over the end of the Camley Street Natural Park, which is it's kind of like an area that nature has taken back over. So it actually there's quite a bit of contamination in that area, but it's now turned into a really nice oasis in the center of the city. So it's crossing over that to get you down low. So it's a connection from A to B. It's also a connection from high level to low level. You can see here, this is just a diagram showing the constraints. So clearance over the canal, towpath on the kind of northeast side, going from high level down to low level. These were the two ends of the bridge before the project started. So you can see kind of the nature reclamation on one end, and even the state of the listed historic structures on the other end. So, as designers, we like exploring possibilities. I think this was an early study just looking at how you make this connection from one end to the other, and thinking of the entire route as a single design exercise. And I think what became apparent was keeping it simple, really pushing. In order to get enough length of ramp, it meant pushing the entire route to the perimeter of the site, which creates a good experience. And it also kind of gives back as much land as possible to the nature reserve, which have since built their new kind of headquarters kind of within the arc of the structure. So trying to kind of do an exhaustive exploration of options, that led to, in the end, quite a simple, elegant solution. So looking at the total length, considering both the approach ramp and the bridge in one move, understanding how the experience shifts as you move along. So at the bottom end, you're kind of in a more secure, more enclosed situation where privacy to neighbors is important, but as you work your way up towards the bridge, it's opening up to the sky, opening up to canal views, and then you're crossing this bridge, which is a lot about lightness, views, openness. Considering the bridge structure itself, which is actually incredibly slender for the span it's achieving. Simple, elegant, refined. One of the original concept drawings showing this. And then here's I think one of the earliest models where it just shows this very simple structure spanning over the canal. It's almost as if it's kind of a hot dog bun wrapped around the space, and the space kind of slips out of the bridge and heads down the hill. So considering the whole thing in one go, the parapets or railings extend down the hill to be handrails. Developing it a bit further at this instance, looking at how the structural kind of stiffening ribs could move to the outside, understanding the impact those would have on views. And then this was a study during planning application stage where there was a shift to orient those ribs parallel to the canal, just to really ensure that boats looking up and down the canal would be able to see past as well as possible. And then here it is just a few weeks ago. You can see the new building at one end and the way it sits very comfortably within this kind of historic post-industrial, quite a rich landscape. And this is kind of what I'm referring to as a kind of inevitability. The way it looks like it belongs there, it looks like it could have been there for a long time. It looks like it could be there for a long time into the future. So that's the sense we aim for, or we hope for, in all of our projects. Again, looking back kind of in the other direction, one of the bits to highlight on this bridge is kind of investing in the parts where people will come into contact. So in this case, the railings themselves are all stainless steel, and they connect to a stainless steel top cord, which catches the light and kind of gives you this very elegant, thin line, bright line crossing over the canal. So now I'm going to move on to Esperance Bridge, which is we see it as kind of the sibling to Somerstown. Same client, same overall site, same design team, fairly different brief, but we think kind of the same design philosophy went into it. And it's quite interesting to see how the result is different, but also similar in some ways. So it is the third bridge at King's Cross. The first we were not involved with, but it's the kind of bigger, heavier, originally car traffic bridge to the east, and then the one I've already spoken about. So this is the site of Esperance Bridge, and you can already see with its proximity to kind of other bridges, it needed to punch above its weight. It needed to do a little bit more than just form a simple connection. It's more than connecting from A to B. So unlike Somerstown, which was this A to B connection about an onward route into Camden or to the west, or up to, for people coming from Camden heading towards Islington, this bridge is about increasing porosity over the canal. It's about providing kind of more options for people moving through the site. It's about connecting Pancras Square to the south through the kind of arcade of shops and restaurants over the canal, and then onwards into Coldrop's Yard. So giving people options. It's also kind of anticipating the high density housing to the north, kind of commuters moving up and down, heading towards the stations at different times of day. historic context was obviously really important, especially on this site. It turns out, while we were digging around, we discovered that there were actually 2 bridges built in this exact location in the past couple hundred years. There was a low-level bridge, and then there was also a high-level rail viaduct coming in from the north. And we actually discovered foundations from both of those bridges as the design progressed. So literally bridges to respond to as we were working on this. And I think this philosophy of, hardworking, functional, efficient, utilitarian structures was clearly an inspiration for us and the rest of the team. I think bridge designers love constraints in a way. I think we like having kind of a puzzle to solve or very clear things we're trying to achieve. So for Esperance Bridge, you've got the canal, towpaths either side, planter on the south, and you have these 2 landings, which are more or less level, which is kind of a nice feature either end. And straight away, you understand most of the structure needs to happen at deck level or above. There's not a lot of room below. You couldn't do like a low arch over the canal. It also tells us if we need a support, where it could go or how the ends can be supported. So again, looking at optioneering, this was one of the first kind of rounds of ideas we presented to the client. And on this bridge, it's only about 25 meters, which is a pretty modest span in bridge terms. So rather than it being a study of, what's possible, this was more a way, what's possible or what's feasible. This was more a way to kind of tease out from the client what this bridge needs to do in kind of a bigger sense, what it, how it appears, how people will experience it, whether it's, trying to show off or whether it's more subtle and modest. And obviously it's a great client. They kind of knew what they wanted, so they were very happy to steer us in a certain direction. So off the back of those, we narrowed it down to 3 schemes. I see the top 2 as more of kind of single gesture schemes where you might have a relatively refined bridge deck supported on a kind of a structure which is a single gesture, whereas the bottom one was more about repetitive elements and putting a lot of emphasis or a lot of kind of design effort into those elements, and how you, by repeating them, you get more bang for your buck. You're able to make the most of a highly crafted system of units. So the bottom one was the one, you could probably tell already, but that was the one that was pushed forward, and we were delighted. And we thought that idea of really honing in on the elements and the details and the connections and the craft and the finish sits quite well within this historic context. So for us, it was exciting. Talking a little bit more about the process, I think the collaboration was very good. In addition to lots of client feedback, we had lots of feedback from Camden and the local planners. They're based quite close, so they obviously had a lot to say about this bridge. And one of the kind of exciting things is they totally got it. They understood why this bridge was important and how it would stand out from the adjacent bridge, and how it would be, a bridge for people, a bridge for pedestrians. It wasn't for cyclists. It wasn't for car traffic. And they actually, despite the outline planning stipulating a 3.5 meter width, they pushed us to make it kind of narrower and more intimate, keep the railings low and keep it really pedestrian scale. So right up till the planning application, we were still looking at the overall proportions, refining it. And then this is a good slide, and this shows kind of how the bridge contributes to the wider urban experience. And it was something we'd kind of had in mind, but I don't think we fully appreciated it until the bridge was there, and you could see the way it encloses. You have the wonderful GAT steps stepping down from Granary Square, where you have events going on all summer long. And this bridge really kind of completes that urban theater. It forms kind of a side balcony, and I'll show you a picture in a minute of people gathering there to watch. They show Wimbledon and they show different movies on the screen here, and you get just this life kind of enclosing the canal, which is really quite wonderful and somewhat unique. The choice of color and materials was something that we looked at from the very beginning, all about kind of working well within the context. Keep going on about context, but for this one, it really was important. So it's just the tone of red, the way it goes well with the kind of the brick and the roofs in the area. And it also sits well within the natural reserve around the corner. So kind of a richness of materials, and actually a boldness as well was something that we were going for. Just really quick, these are slides that are usually presented by my engineering partners, but I'm going to go through them quickly. So just talking about, it's almost goes without saying at this point, but the ability to share models and files and information was important. On this one, I'm pretty confident to say that this was probably the closest experience I've had to being able to work on a model and pass it off, and it gets passed off again, and then the built result is almost exactly the same as the original model. So I think that was quite exciting. I think having the contractor and the fabricator involved early on, we knew what to model because we knew what they wanted to build. So it was a really fluid process. This is a picture of the abutments before we did anything. So you can see the master plan anticipated this bridge. So there already pretty much was a landing there, even though I don't think anyone realized it was meant as a bridge landing, but you had a landing at either end. Like I said before, they're at almost exactly the same level, despite Goods Way on the south sloping downhill. So you've got these two tie-in points at the same height, which is ideal. One of the biggest kind of carbon success stories on this project was the fact that that wall to the south, there's actually a retaining wall in here. The engineers put a lot of time into surveying and studying and testing that wall to determine whether or not it could support the load of the additional bridge, and it could. So that meant we pretty much had a free support at one end, and as that's the kind of most carbon intense part of the project, we're delighted to get that for free. At the north, what you can see here, this big hatched area is the old brick supports from one of the old viaducts. There was some kind of complication around that, but in the end, we were able to use it to stiffen up the area as we piled through to create a new abutment. We looked to reuse it, but just the need to rely on it for the next 100 years meant it was a little bit hard to convince everyone that would be possible. The truss form itself. So this is, trusses are a pretty tried and tested solution, quite a good structure for this span. It puts the structure within the parapet, so the structure is the parapet, which is a good advantage. And here it's about kind of reinterpreting that traditional Warren truss, using the plates and the geometry, kind of expressing the forces. So you have struts, compression struts articulated in one way, and then tension ties very much articulated to showcase what they're doing. Sections are T sections in profile, so they handle buckling in both directions. Essentially, all the plates are working in a very specific way, and their shape and articulation is tailored to that function. And an example of that are these tension tie details, which I think were always meant to stand out. They do catch people's eye. I think the level of craft that went into them is quite good. The complexity of building them was not straightforward, but it was something we had ideas about early on, and good design meetings to flush out the solution. One of the things we felt really strongly about was the way, kind of the user experience here. This idea, literally, you're taking the kind of stone paving of Granary Square and pulling it across the bridge. It meant a much sturdier, solid feeling bridge than you might find other places. But it also meant, in order to do that, we needed a really robust structure. So the way it works is it's actually what we call a steel bathtub, where you have a steel shell and then it's infilled with concrete. So the steel and the concrete work together compositively, and then you lay stone on top of it. The second advantage is this is the way the bridge came to site. So it already had parapets up, which meant a safe working environment for the people pouring the concrete and laying the stones. Mock-ups, samples, all of that stuff really important to the process. This was a mock-up we commissioned kind of midway through the design, just to test the feasibility of bending these quite thick plates, welding them back together, grinding it, sanding it, making sure it was smooth, and then painting it as well. So this was a mock-up which was actually on site for a couple months in the summer, and it almost looked like a bit of sculpture. So here it is in the workshop up in Yorkshire. Going up to visit that was one of the few chances we had to get out of our apartments back in the heart of COVID, but it was a controlled visit, and it was quite great to see it coming to life. So in the shop, built just small enough to fit on quite a big lorry, transported to a paint shop nearby, and then straight down to London. And then here, I'm going to try to play a quick video just taking you through, seeing one of these arrive on site, get installed in a day is one of the most satisfying feelings I've experienced. So there it is. You can see right away, boats are going under it again. So kind of nice to see a well-planned thing, well executed. I think this, again, going back to this feeling of belonging, the way a structure can feel at home, comes right down to the finishing details. So in this case, looking at the way the bridge meets the land, I think the kind of four corners received as much design input as the entire rest of the structure. So working on that, making all of that kind of disappear to everyday users, concealing the abutment chamber within brick-clad doors, things like that are really important to us. I think Carlos mentioned in the introduction that the bridge was named by a local school who did a unit in bridge design, and they also looked at the history of the neighborhood, and they came up with a name that was fitting to the neighborhood, and we were quite flattered and pleased that we were able to involve them. Just very quickly, I think this was a carbon rating which has only come online within the bridge community in the last year or so. So we didn't have the opportunity to evaluate the bridge during design, but afterwards we've gone back and done an assessment, and we're pleased. I think it scores fairly well. I think one of the reasons it scores as well as it does is because of that southern abutment. Obviously a lot of steel went into it, but I think that's part of this solid feeling, solidity of it. And this is just seeing it kind of in operation. I believe this was during Wimbledon, so you can see it there as, one of the viewing platforms. And just a nice quote from the happy client saying how, how important this is as a bridge, as a destination, as something that will draw people through the space, and kind of its effectiveness of doing what we set out to do. Yeah, so that's it. I think
Thank you very much, Ezra.
Yep, my pleasure.
Thank you very much indeed. That was fascinating, really fascinating. I've always been a bit ambivalent about the whole kind of private nature of the King's Cross regeneration, but every time I go there, I can't fail to be impressed by the level of the general design quality of that whole of the whole Argent development there. I mean, you might take or leave some of the office buildings that are a part of that wider regeneration, but the actual effectively public spaces going on in Granary Square and around it are really quite special. And I think you've kind of built on that quite.
Yeah.
A couple of comments actually. The first one, when I saw that bridge going in, I thought, what the hell are you building another bridge just about 30 meters away from the crossing, the main crossing into Granary Square? But the experience of those two things are extremely different.
Yep.
Crossing just feels like a kind of a run of motorway. You don't even know you're on a bridge when you're passing over that. There's no experience of that at all, effectively. Not really, not even when you're on the edge of it. The Esperance Bridge feels like a very, very different kind of urban experience. The idea that you are physically crossing. It's quite a ceremonial crossing.
Mm.
And then there's a difference between the Esperance Bridge, which has a kind of flamboyance, I suppose, because you're just seeing it from so many, you're seeing it publicly from so many sides, and I'm sure that was a consideration that you kind of thought, well, it's actually being seen. The King's Cross Bridge that goes through Camley Street is a very, very different, it's kind of a slightly clandestine experience of passing over. You only really experience it visually if you're kind of going underneath on the more quieter canal part, the towpath sides. And your experience as a user is you're kind of like drawn up through the canopy of the trees as you pass through onto the bridge itself. So it feels it's a very, very different kind of almost hidden experience. And I think the way that you approach them, one with this idea of really responding more to the users who are passing underneath on the actual barges themselves, that you're more thinking of them really, of how the kind of the ribs of the structure be seen by them and give them clearance of view, as opposed to Esperance, which is really about the flamboyant idea of the expression of the bridge for people, for either users or people who are passing it who aren't using it, but just merely passing it by. And I think that kind of joy of the one with that kind of industrial aesthetic of the other, and the counterpoint of the two makes them a really lovely pair of bridges because they talk about completely different ways of experiencing it.
No, that's great. I mean, you've said it really well. I think that a lot of that was basically what we were trying to do and what I was trying to show here today. And I think the use of the word flamboyant is something we were going for. And it's not something we always are encouraged to do as bridge designers. But in this case, the client brief was actually to create, a landmark in the sense of, let's meet on the red bridge. We're going to get dinner. Meet me there. Or how do I get to the shop? You cross the red bridge. It's something that serves as a landmark that people kind of know about, or it's easily recognizable. And the experience of crossing it is hopefully memorable. And that was what they want. They wanted that. They didn't want another kind of subtle bridge, which they already had. So I think it's serving its purpose so far.
Yeah,
so
absolutely.
It's nice to see it kind of
well
received.
No, totally. It's a lovely bridge. Well, Bob Eden here said it's another example of the outcome exceeding the original imaging. So refreshing. I doubled that. It looks fantastic as it installed. And Alexander saying, which type of steel did you specify and apply? Did acid resistance play a role? Could a similar result have been achieved with a timber bridge? I suppose he's just looking at the embodied carbon aspects of it. But.
Yeah, I mean, interestingly, at one point this was a timber bridge scheme, and we pushed it really hard. But I think we were trying to get timber. We were trying to do the truss with timber members, and I think we were pushing them to do something they didn't want to do, and it was actually the connection between timber elements that let us down, and we couldn't. They were going to end up being way chunkier than the timber itself, and it was losing its elegance. So
yeah, but isn't I mean, that's generally what everybody says about timber structures. Generally, is it's not the structure; it's the connections.
Exactly.
It doesn't really mean that you end up with that's why Hopkins went for kind of when I remember the structure over at what was it, up in Annick Garden, where they're they come back to this idea of steel connector effectively. And could you have imagined maybe a hybrid structure that would have kind of used, the kind of tension rods that you even used here, as opposed to the compression? So using timber compression struts in effect, but using timber.
I think absolutely, but I think that's kind of speaking to me to like a longer span structure, whereas this one, I think because it's small and because it's kind of human scale, had we gone for one of the more refined, simpler, elegant solutions of just a simple beam, like you could imagine a very well sculpted timber slab going over the canal, but I think it wouldn't have drawn the eye in the same way. We are actually working on some timber structures, and I'd love to come back and share one of them at some point in the future, because I do think there's huge potential, and they are, they're more and more common in Germany and Europe, and I think hopefully we'll get to build one over here soon. But huge potential. Going back to the steel, carbon steel and then stainless steel. So it's painted carbon steel, all the red. I can't tell you the exact grade of it, but it's well protected with the steel or with the paint protection system.
Given that you could model it the way that you did, and you could effectively do whatever you want, really, within reason, what made you kind of stop where you stopped? Because it's a very elegant, it's very elaborate. There is a kind of the whole kind of folded nature of it, it's curving, folded nature. What made you kind of stop there? I mean, at what point did you kind of go, that's it? Yeah, then we're there. Why did you not kind of think, could we take it a bit further? Can we fold it a bit further? Can we kind of give it more dimensionality? What point did you stop?
I mean, I think we were satisfied it was expressive enough, but I think kind of what's missing from this discussion is the more engineer focus aspect of it. The way that every one of those plates is really doing a function, and it was about not doing any more than it needed to do. So, an engineer would say this plate needs to be 300 mil wide in this direction and 15 mil thick plate. This orientation is effective because it's, dealing with a load, or it's angled in a way that prevents kids from stepping on it. So it was it was serving all the functions it needed to do, but it was also looking quite good and as kind of tight and tidy as it could be. I think once we achieved that and we knew through the mock-ups it was buildable, I think at that point we were pretty satisfied. And then we just looked at the ends and tried to resolve all those other details. So yes, designers, of course, we could have done iteration after iteration, but at a certain point, it was, working for all the different parties, and we were pleased with the way it looked and the way it was performing. So it was time to move on and get it built. I mean, we had a certain amount of time to do it, and we used that time, but.
We've got one question from Adam Pearson saying, is it a concern when elegance trumps environment? So I think he's calling you on your choice of steel, I suppose, there. I mean, obviously you consider those things. Yeah,
it's a good one. And I think, every project we're doing now, we are kind of assessing the carbon from first principles. It's not a kind of afterthought. So had we done this, starting now, we might push harder to keep carbon down. Maybe we would question, a lot of it went into creating the solidity to do the stone deck, and we would maybe consider whether that's worth it. I mean, I do. When you experience the bridge, it feels right. It feels solid, like public realm. But there is a cost to that, and I'm not sure as we keep moving forward if it's worth it. So I absolutely sympathize. I think it's a good discussion, but I do think you can be elegant and sustainable.
Just one more question from me, and it was really about the I'm noting the time, really overrunning, but I just wanted to ask it about the actual material you chose for the floor itself, the floor of the bridge itself. I mean, I've just been disappointed, I have to say, by, much as I love the elegance of the Millennium Bridge, and I really, really, even though I walked over it before it was really fully open, I never got to walk in it when it bounced, and that's one of my big regrets, is that I never walked on the bridge when it bounced, because I've always loved the idea that bridges should have a certain amount of flexion in them. I kind of think it's part of what makes them a bridge, is the idea that that we have to kind of change the way that the way the Albert Bridge, you have to break step when armies walk across it. So I think that the materiality of the floor I thought was interesting. Say with the Millennium Bridge, I don't really like the floor. I don't like what you walk over when you're walking over the Millennium Bridge. I so wish it was timber planks. I still do. Every time I walk over, I think, what a nice counterpoint it would have been with a steel structure to have massive, thick timber boards that would kind of age over time. And I'm kind of, your choice ultimately of deciding to kind of run the floor of the thing over. I can totally see if you're looking at it in plan in terms of the experience of seeing the material run over to the kind of the south side of the development. But actually, I rather like the idea that the bridge has its own materiality, which is distinct from what's around it. Just a comment.
No, it is a comment. And I mean, it's the same stone, but it's in a different pattern. The layout is specific to the bridge. So yeah, I think we acknowledge you are crossing a threshold. But yeah, it is a specific experience that you're extending that kind of solidity and thickness of stone across the bridge. But those are all, they're good points, and they're things we spend a lot of time thinking about.
Yeah, no, obviously. Well, thank you very much indeed. There was a question from Simon just asking you if you could talk a little about the lighting and preventing retrofitting unconsidered fittings at later dates. Can you do that in like 10 seconds?
Yeah, it's a whole topic I should have talked more about, because lighting is a really important part of this bridge. It goes to that landmark thing of the lighting. I think our hope was the lighting would highlight the design itself, and I think it does. I didn't show any night shots, but there is a pretty serious lighting system on the bridge, and part of it, the client has put in event lights, which will be in place during the winter, so you'll be able to light the outside of the bridge. And if anyone's been there recently, they're on there now. As the first fitting, they're not fully integrated, but hopefully they'll tidy them up a bit. So the idea is during the winter, they'll be able to do color change, feature lighting, and kind of tie it in with the lighting of the rest of the estate. So if you know the area, the fountains often are lit up in different colors, and you have that link down to the tube station, which is a big lighting installation. So all three of these will be able to be lit in a similar fashion. So it is a big part of it, but it's something I just didn't get into on this presentation.
Well, thank you very much indeed, Ezra. It was a fascinating conversation. Thanks a lot.
Thanks for having me.
Cheers. And our last sponsor presentation today is going to be from Adam Smith, Managing Director of WOHR Parking Systems. Welcome back, Andrew. Apologies, I'm running really late, and I'm really sorry about that. But thank you very much indeed for presenting. Andrew,
no problem.
A subsidiary of WOHR Multi-Parking Germany, which in '95 became the UK company WOHR Parking Systems. Since then, he's helped shape and develop the whole concept mechanical and automatic parking systems in the UK. He works with architects and developers on a daily basis to develop solutions that meet cost and performance needs with experience and expertise that is, quote, second to none in the UK. You've pretty much got that market sealed up, I should imagine, Andrew, not least with the fact that you're going to be talking about a Knightsbridge project where every inch of space counts, no doubt.
Absolutely. Yeah. I think, the market has changed for us over the, would you believe it, 30 years since I started doing this. And I think, whereas in the early days it was as every developer was trying to eke out every parking space, now we're coming from a different direction and saying, well, we're going to probably put some accessible spaces in this building. We don't want to take off a lot of the space inside the building. So how do we reduce that volume, that spatial volume that cars take? I mean, we've got about 33 million of them in the country at the moment, and it's a big spatial problem, particularly for urban areas and where we decide to put parking spaces. The environment's changing. We've heard a lot of talk today about urban spaces and its quality of life, and to give human beings back their city landscapes. Whereas at the moment, you look at a cityscape from the origins of the car, and every street is full with them. There's no spaces for human beings now. So it's trying to be cleverer about how we create transport nodes, what we do with the car, when we use it, when we don't use it, when we do use it, where we put them. how do we get all those connecting points right and not end up with a big conflagration of parked cars, which is ugly.
Exactly. Well, I mean, that's the problem with King's Cross. I mean, that was another discussion altogether.
Yeah.
You're managing it is a car.
Totally.
Everything runs around it. So, needless to say, I don't even know whether your systems are integrated anywhere around the King's Cross development, but I imagine somewhere they are.
Well, yeah, we are having a lot of talks at the moment because it's a slightly off subject, but we also do automated bicycle parking machines just to save space, get them underground, out the way, and secure them. So there's a lot of ongoing discussions at the moment with large transport nodes that we can just be a help, a tool, and a toolbox. I think that's...
Well, you're talking about Knightsbridge, but maybe in your next presentation you can maybe talk about how you're going to deal with parking our bikes.
Yeah, maybe that's the next one. Yeah, I think everybody will find that quite interesting. It's fascinating.
Well, take it away, Andrew.
All right, here we go then. So I'm just going to share my screen. Here we go. So, we are a German company. We're the UK subsidiary. And what I'm going to do today really is talk about space efficiency. As I just mentioned with Carlos there, the market has changed, the environment's changed. I think people's view of the car has changed and is changing. So it's still a problem. As I mentioned, about 33 million of them in this country, which as a big box of metal things is a huge storage problem. And also now we're thinking a bit deeper about integrating them into our transport nodes, hubs, trying to create more urban spaces for people, for quality of life. And we've been doing this for many years now. It's very big in Germany and continental Europe. And we've really been slightly tail end Charlies, probably running about 10, 15 years behind them in what they're doing. They have gone to the point of even digging up streets and putting all the cars underneath so it creates urban space. But all I'm going to do today is around about 10 minutes just to show you a huge subject. We make around about 100 plus different models, all for different circumstances, different shapes, to do different things. So what I'm going to do is just talk about how they space save, and then go on to a real project, one that we did in Knightsbridge called Kensington Gardens. So let's have a look at a case study. This is just one. This is stills from a video we created just to show people conventional parking compared with one of our semi-automated parking systems, and the difference just in space usage. So, for instance, this used an example of a 40-space underground parking system or parking space. Originally and traditionally, we would build that with ramps and concrete decks and a great big excavation to create it. And we worked our way through all of the concrete slabs, the walls, the floors, the M&E services, all of the finishes and fittings. And it came out that with an automated parking system, we actually saved just under 53% of the actual materials used. And, in this day and age of environment, sustainability, that is a huge, significant build cost and saving on Earth's resources. So this was an example that we did, and it broke it down into a pit excavation, 52% saving. I won't bore everybody with going through each of the stats, you can read those, but it's interesting that bottom line, the occupancy, which is what we're always determined to try and find, is the ultimate efficiency for the occupancy. So what that is saying is we've used almost 80% of the space that's been created just for the cars. So there isn't that huge amount of wasted space with ramps and everything else. Broke it down further. a 49% advantage on energy, 51% CO2 saving, and 52% material saving. So it's significant. And, we are finding in various projects, we work with architects, we work with developers to actually find the optimum way of making it work and be sustainable. One of the projects, right actually in the centre of London, in Knightsbridge Gardens, originally called K1, Fletcher Priest Architects designed the building. Quite a complex development, obviously, at that busy junction, Harrods and Harvey Nichols, and that the main Cromwell Road running right in front of it. The facade was a listed facade which had to be maintained, and they had to get an awful lot into the building. So, even almost about 32,000 square meters of office and retail space with the 35 residential units. So the last thing they wanted was to have large space taken up by parking space for the residential units. They only wanted 19 spaces. And so we worked along with them to create and work out which system was the most feasible and practical for them. This was a semi-automated system. And as I said, we make over 100, but basically parking systems are grouped into 3 groups. Stackers, which are just basically up and down machines, hydraulic. At the other end, they're fully automatic systems. So you have entrances, multiple entrances, and they park vertically above or below ground, and they can be very fast, even for public parking. But in the middle ground, there's often systems that people don't know a lot about. What they are, though, is some of the most space-efficient systems that you can have. So the Combi 543, which we call it, is a 3-level system. So it's 3 levels and is built in a modular way of steel frames, and we lose 1 parking space in whatever grid length we create. So on this particular system, we calculated, compared with having 19 spaces with their aisles in front at 6 or 6.5 meters, we saved just under 60% of the space that would normally be used for 19 parking spaces. So this is how it works. It's the sort of the ultimate stacker, really. We were often asked, with a double level stacker, we've effectively got 3 volumes of cars as they move up and down. But although spatially quite efficient, they're not quite as efficient as they could be. So this was a system designed originally in the mid-80s to only lose 1 space in the whole system. So we just have, on that sliding space, on the entrance level, we just have 1 sliding space, which allows then everything else to move. So what we're going to do now is just actually go on to the real project in Knightsbridge just to see physically what it looks like. It was a promo video, so excuse the music and the salesy part of it, but it just gives you an impression of how it actually works in reality. Welcome back. Hope you enjoyed that. It was just good to see the reality of the parking spaces. My next slide really was, we often get asked now, and we've had to move on with the times. How do we interface with all the other parts of control, buildings, security systems? So this is something that we do now on a quite regular basis. And it's all about integration with everything else that's going on to make it a nice, enjoyable experience. So for instance, on this project, we have the building security system. So everybody has a key card to get into different secure areas of the building. We also made that as an operating card for the system, so you can call your card from the RFID signal boxes from the building security. We have our own as well. That's always a good backup to have. We always fit our own panels. Remote control, so people can call their cars just by sitting inside the car and actually operating a remote fob. In addition on this one, the client had an ANPR number plate recognition camera to enter the building. So as soon as the car actually arrives at the building, detects the correct number plate, that will actually call our system and the car parking space and open the door ready to drive into. So more shots of the system. So on this one, we've got quite a few special finishes, powder coating, aluminium platforms, and EV points. EV points is a good question. A lot of people now, we need to put EV points on everything. It's a standard option. Trickle chargers for some particular cars as well need it permanently. So that is all incorporated into all the parking spaces on all of the systems. Some questions we get asked about services. Can we put sprinklers in to the system? Yes, we have standard diagrams to show sprinkler companies how to actually incorporate it. Where do we put services? We're aware that services need to run around our system. So we have services zones that we can show architects and M&E services people exactly where to actually put them that doesn't interfere with the movement on each project. After sales support, systems are no good unless they run all the time. Obviously, inherently, we design them to be fail safe. So if they have any failure within them, they will look at other sensors to make sure they keep running. We will be contacted directly by the system itself. So our engineers immediately know if there's any faults occurring. And obviously we have 24-hour coverage with our on-site maintenance teams. So that was, again, a whistle-stop tour of the whole concept. As I say, it's a huge concept, but that's the essence of what we're trying to do, is just make storage of cars in a smaller space than you would normally need to park them where they are parked, and how we then can help to integrate that into transport nodes, hubs, and many other things that we're talking to people about at the moment.
Thank you very much indeed, Andrew.
Hello.
Thank you. Yeah, I mean, it was quite interesting when people asking you about kind of sprinkler provision and these things.
Yeah.
From remembrance, I remember that car parks are actually one of the least likely places you're ever going to get a fire breakout.
Well, car technology has come on so much. I mean, there are still, lots of discussions going on at the moment about electric cars and how fire departments tackle those. But in actual fact, yeah, the stats are very good for car parks as far as fires are concerned. But there's a lot of talk at the moment about different modes of transport. Whatever these car personal transportation bubbles that we have for now and in the future, what powers them, and is that going to have an effect on the fire risk in concentrated parking areas? There's obviously, we've got the EVs, we've got hydrogen-powered vehicles, and obviously the old combustion engine. It's a little bit probably beyond my pay grade to sort of work out, but I'd sit in many design team meetings chewing over the whole subject, with the fire department, how do they handle it? And this is a question all around the world at the moment, particularly with EVs, because they're very difficult to extinguish once they get going. So you need
obviously, yeah. I mean, they've even got that with the Uber bikes, haven't they, and all of that?
Yes, yeah.
Bikes just catching fire and causing fires in flats.
Yeah.
Yeah.
Yeah, so you've almost, I know we work with a lot of, fire sprinkler people, mist systems and people like that can actually create enclosures. That means that they will actually seal a fire into an area. We've talked a lot, and I've been in design team meetings with oxy-reduction companies that can literally take the oxygen out of the atmosphere, which actually slows a fire down tremendously, but still allows you to breathe.
Yeah, wow.
Yeah, but I say that's almost, we touch on so many different subjects. When we just supply mechanical parking systems, we have to know a little bit about everybody's remit and where they're coming from and what their fears and problems and issues and everything are. We have to find out. We often put people in touch with each other to say, well, you talk to him and her, and then we'll join in the conversation. It's a fascinating subject.
Well, Bob here said it's obviously a major saving on construction, but has there been work done to compare operational costs of ramped and automated systems?
Operational costs. We've done some rough calculations. I mean, it's very similar, in our very rough calculations, but it probably is something that we need to publish to actually show people the nuts and bolts of how it builds up. Obviously, with a mechanical system, it does need to be maintained. They will break at some point. Some component will need replacement, but they are pretty. The first question I get asked ever is, how reliable are they? We've got about 8,500 spaces here in the UK now. In Germany, they've got around about 500,000 in Germany alone. Of our 8,500 spaces, they range from stackers, very simple devices, all the way up to multi-story fully automatics. But I mean, an automatic, we have an automatic in Birmingham, 339 spaces, call outs once a year. And we usually know about it before it happens anyway, because the system sends our engineers messages. So we can say, sensor on this travel is not reading every time, and that sends us a fault code. So we can go, okay, probably not urgent tonight, but tomorrow morning we go by and do that. But good point. I think that is probably something that we need to demonstrate properly, that comparison.
And I assume that just a final question from me being about, if I parked up my DV7, I'm now in a situation, given the fact that you've now got the technologies to allow for it, that by the time I've gone down in the lift from my penthouse, the car's waiting for me by the time I get down there. There's no waiting time on my part.
No. We have them in apartment buildings where you have the car call next to the lift call. You can control a lot of our systems now by an app. So you can call your car on your phone. There's a little bit of risk with that. It's as much as our phone manufacturers will tell us everything is secure, it isn't totally secure. So we have to be talking to clients about where it is, how can people get to it, could they, if they break codes, get into calling people's cars. If that's the case, we recommend no, don't use apps. From our point of view, particularly with automatics, we're trying to disguise the machine time from the user. So the user has a lovely experience. As they drive into the ramp, we have a system, I think we talked about that last year at One Tower Bridge, as people arrive, an RFID signaler unit reads the car, the doors open, the security checks before the doors to the garage open. Our system has already prepared the space, open the door, straight in, and the same coming back out.
Oh, wonderful. Well, to that at some point, at unstipulated points in the future when I do have an Aston Martin.
You don't have to have an Aston Martin, honestly.
Thank you very much indeed, Andrew. I realise I've now I did have my little round. Try and be philosophical and poetic about the ideas of vision and heritage, which I think all of these projects, which the architect presentations kind of touched upon. But given that I've overrun 25 minutes, I think I can probably spare my my viewers at the moment for that one. Or it just leaves it to me to thank our presenters, Frank Anatole of Network Rail, Hugo Braddick of Haworth Tompkins, and Ezra Groskin of Moxon for their presentations, which were all fascinating, which is why we've probably overrun because I can't stop asking questions. And I'd like to thank our sponsors as well, Ben Hancock of Oscar Acoustics, Tim Boarer of Mapei, I hope your cough gets better, Tim, and Andrew Smith of WOHR Parking Systems. Thank you very much indeed for your presentations. Our next PiP webinar is going to be on bespoke housing design, which I'm sure will be wonderful because generally most people seem to be really into looking at other people's private houses. And that will be on the 15th of November, so do join us for that. And in the meantime, I hope you have a wonderful day. Thank you very much indeed for your time.